Hi, I'm Daniel. I actually took this class last year and I'll provide some helpful videos on the upcoming labs. So for the moment of inertia lab, there are a few equations we'd want to look at. The first one is Newton's second law, which is force equals mass times acceleration. The second equation is where torque equals the moment arm crossed with the force. In this case, we'll be measuring the force of the falling object. We'll also be looking at rotational inertia of a point mass, which you will come across in your dynamics class. And in this case, the moment of inertia is equal to mr squared, where m is the mass and r is the distance between the center of mass and the point of rotation. We'll also be using the parallel axis theorem, the total moment of inertia equal to the moment of inertia at the center of mass plus the mass times the distance between the center of mass and the point of rotation.
Squared.
You'll also need the rotational inertia equation, that is moment of inertia is equal to tau over alpha, where tau is torque and alpha is the angular acceleration. You'll also be measuring the force of the pendulum is equal to mass times the acceleration due to gravity, sine theta, where theta is the angle of oscillation.
Hi, I'm Maddie. I took this lab last year, so I will also help demonstrate some of the labs through the semester. So the first lab that I'll demonstrate is the moment of inertia lab, which Daniel introduced. This mass that we have attached is actually only going to be used for method 1. We will not use it for method 2 with the oscillating pendulum, and you'll see for yourself why when you get into the lab. So the first thing I'm going to do is demonstrate how we will go about adding an object in order to get this mass to rotate with this falling object. So I'm going to add just a slight mass to start out with, and then we will introduce the software a little bit later and show how we start the software before demonstrating the release, but I'll go ahead and show how this is going to look so that you know what it looks like coming into the lab. So first I'll release my hand. Now we can see that the mass is rotating freely and the object has fallen. So again, we will see in the software later how this looks graphically, but in order to determine the moment of inertia, what I would do is determine the moment of inertia of this entire object. I would remove this upper mass, determine the moment of inertia of just the silver disc, and then I would take the two moments of inertia that I find and subtract them in order to obtain the moment of inertia of just the solid black mass. So that's just one demonstration. We will use other masses as well to determine the different moments of inertia that are present between objects. Method 2, the oscillating pendulum, is going to be a lot easier than method 1. All we have to do is attach our mass, and then when we're ready, we'll go ahead and hit start on the software. We'll give a gentle tap to one side of the object and watch it oscillate and see our results graphically.
To start, open up Pasco Capstone software. This will be used with the Pasco Universal Interface to record the angular velocity, angular acceleration, angle, and a few other metrics. Once you've opened the software, go to the right column and drag the graph icon onto the main page. After doing that, select your desired measurement. In this case, I'll be looking at the angular velocity on channel 1. Make sure you're reading from the appropriate channel. In this case, I'm looking at channel 1. And it defaults to a sampling rate of 20 Hertz. We can increase this to get a finer quality sample. So I'll look at it at 40 Hertz. When you're beginning your run, click the record button, like this, and measure and how the angular velocity changes with time. So once we have the graph that we want, we'll go into File, Export Data. We'll go to our group folder, and we'll save the file as a CSV. And make sure you name each of your files differently, or else you'll be overwriting your previous runs. and losing the data associated with that. To get another page, go to Workbook and hit Add Page, and repeat the same process to get the appropriate channel setting. This time we'll be looking at channel 4, which is the pendulum. And for this, we'll be looking at the angle that is measured. All right. As you can see, the angle is being measured as the pendulum swings back and forth. And we'll do the same export on the data to save it.